Ever wonder how Spotify just knows what new song you'll love, or how Amazon suggests products you suddenly realize you need? It's not mind reading. It's a fascinating branch of artificial intelligence called unsupervised learning. And today, we're going to demystify it completely. So, what is unsupervised learning? Imagine you have a massive box of mixed up Lego bricks all different shapes, sizes, and colors. Now, imagine asking a robot to sort them. But you don't give it any instructions. You don't say, put all the red bricks here, or group the 2x4 blocks together. You just say, organize this. The robot starts looking at the bricks. It notices some are red, some are blue. Some are square, some are long. It begins creating piles based on these similarities. One pile for small blue pieces, another for large yellow ones, and maybe a weird pile for all the transparent ones. It's finding patterns and creating groups all on its own, without any right answers or labels provided by you. That, in a nutshell, is unsupervised learning. It's the art of letting an AI explore a dataset and discover its inherent structure all by itself. Unlike its cousin, supervised learning, where we give the AI labeled examples like this is a cat, this is a dog. Unsupervised learning is all about exploration and discovery in the wild. One of the most common and powerful techniques in unsupervised learning is called clustering. This is exactly what our Lego sorting robot was doing. Clustering algorithms are designed to group similar data points together. The core idea is to maximize the similarity within a group and minimize the similarity between different groups. Let's take a real-world example. Customer segmentation. A large retail company has data on millions of customers, what they buy, when they buy it, how much they spend. Labeling each customer manually would be impossible. Instead, they can use a clustering algorithm. The algorithm might automatically identify several distinct groups. For instance, Cluster 1 could be bargain hunters who only buy items on sale. Cluster 2 might be high-value spenders who frequently purchase expensive electronics. Cluster 3 could be new parents who buy diapers and baby formula. The business never told the AI to look for these specific groups. The algorithm discovered them just by analyzing purchasing behavior. This is incredibly powerful. Now, the marketing team can create targeted campaigns. They can send discount codes to the bargain hunters and showcase new premium products to the high-value spenders. This is far more effective than sending the same generic ad to everyone. It's personalized marketing, powered by unsupervised discovery. Another fascinating application of clustering is in genetics. Scientists can analyze thousands of genes from different individuals and use clustering to identify groups of people with similar genetic profiles. This can help uncover links between certain genes and diseases, paving the way for new medical treatments and personalized medicine. From identifying social network communities to organizing vast libraries of documents by topic, clustering is the workhorse that brings order to chaos. Now, let's talk about another cool, unsupervised technique. Anomaly detection. As the name suggests, this is all about finding the odd one out. It's about identifying data points that don't fit the expected pattern. Think of it as a digital detective that's exceptionally good at spotting irregularities. Imagine you're running a credit card company. Thousands of transactions happen every second. How do you spot a fraudulent one in real time? You can use an anomaly detection model. The model learns what normal transaction behavior looks like for a particular customer, their typical spending amount, location, and the types of stores they visit. Then, one day, a transaction comes in that is completely out of character. A small purchase in their hometown, followed 2 minutes later by a huge purchase for a luxury watch in a different country. The anomaly detection system immediately flags this as highly unusual, a major deviation from the norm. It can then automatically block the transaction and alert the customer. This prevents fraud before it even happens. The system wasn't told this specific pattern is fraud. It simply learned what's normal and flagged what wasn't. This same principle is used in many other fields. In manufacturing, it can detect a faulty machine on an assembly line by spotting unusual sensor readings. In cybersecurity, it can identify a potential network breach by recognizing abnormal data traffic patterns. Anomaly detection is our silent guardian, constantly watching for the unexpected and protecting our systems from potential threats. So we have clustering to find groups and anomaly detection to find outliers. What if you want to simplify your data without losing its essential information? That's where dimensionality reduction comes in. It sounds complex, but the concept is quite intuitive. Imagine you're trying to describe a car to someone. You can list hundreds of features. The exact diameter of the steering wheel, the material of the seat fabric, the wattage of the speakers, the specific chemical composition of the paint. That's a lot of information, and most of it is probably not that important for just getting a general idea of the car. This is a high-dimensional description. Alternatively, you could just say it's a red two-door sports car. You've just reduced hundreds of features down to 3 key components: color, body type, and class. You lost some detail, but you captured the essence. This is dimensionality reduction. It's a way of taking data with many features or dimensions and summarizing it with fewer, more meaningful features. In machine learning, data sets can have thousands of features. This can make them slow to process and difficult to visualize. Dimensionality reduction techniques like the famous principal component analysis or PC help us find the most important underlying patterns and represent the data in a simpler, lower dimensional space. This makes data easier to plot and understand, and can even improve the performance of other machine learning models by removing irrelevant noise. So, we've seen how unsupervised learning can group data, find outliers, and simplify complex information. What are the big pros and cons? The biggest advantage is its ability to find hidden gems. Unsupervised learning can uncover patterns and relationships in your data that you never knew existed. It offers a fresh, unbiased perspective, free from human assumptions. This can lead to breakthrough insights and genuine aha moments. Another huge plus is that you don't need labeled data. Labeling data is expensive, time-consuming, and sometimes just not possible. Unsupervised learning lets you dive right into your raw data and start exploring. However, it's not without its challenges. The biggest downside is the ambiguity of the results. Since there are no right answers or labels to compare against, it can be difficult to evaluate the quality of the output. Did the clustering algorithm find meaningful customer segments or just random arbitrary groups? It often requires a human expert to interpret the results and validate whether they make practical sense. The algorithms can also be sensitive to their settings, and finding the right configuration can sometimes feel more like an art than a science. For anyone in tech, business, or data science, understanding unsupervised learning is no longer optional. It's a crucial part of the modern toolkit. It's the engine behind recommendation systems that drive e-commerce, the detective that finds fraud, and the explorer that charts the unknown territories of complex data. It empowers us to make smarter, data-driven decisions by revealing the stories hidden within our data, without us needing to know the plot beforehand. It has a fundamental shift from just answering questions to discovering what questions we should even be asking in the first place. So the next time your music streaming service suggests a band you instantly fall in love with, you'll know the magic behind it. It's the silent, unsupervised genius working behind the scenes, connecting the dots you never knew were there. I hope this deep dive has demystified the world of unsupervised learning for you. It's a truly powerful and exciting area of artificial intelligence. If you found this video helpful and want to learn more about machine learning and data science, please give it a thumbs up. And do you want to forget to subscribe to the channel and hit that notification bell so you know when I start next video. Thanks for watching, and see you in the next one.